So welcome. This is your lesson on 11.2, complex numbers. Complex numbers is, before we get into what a complex number is, we are going to talk about what an imaginary number is. Okay. So remember, this is a little bit of a review. Imaginary numbers R is just I, right? And I equals the square root of -1. So whenever you have a square root of a negative number, we just pull out that negative by pulling out an I, and then the simplification, and then you can simplify the square root by pulling out perfect squares. And doing all of that simplification where we learned before. Correct? So remember that I squared equals -1. And please refer back to the old notes or the old YouTube video on complex or on imaginary numbers if you guys are lost on how we derive those two. Okay, so what a complex number is, and what I'm going to do is I am going to make like a little Venn diagram here. Okay, so this, excuse me, there's two circles, and one of the circles is filled with real numbers, and the other circle is filled with imaginary numbers. Okay, so a real number is like all the numbers that we know, right? Like 2 is a real number, 4 is a real number, a -3 is a real number, square root of 5 is a real number. Anything that we've worked with so far, 3/4 is a real number, right? An imaginary number is any number with I in it, correct? I is an imaginary number. 2I is an imaginary number. I square root of 5 is an imaginary number. 7.3i is an imaginary number. Okay, anything with an I in it is an imaginary number, right? Okay, what a complex number is now, what we're going to get into today, it's just a real number plus or minus an imaginary number. Okay, so we just get two elements or one element from each, and we're adding them or we're subtracting them. Okay, so I'm going to get a 2 plus, and I'm going to I. That's a complex number where there's a real component and there's an imaginary component. Okay, do not overthink this, right? That's how simple it is. All right, 4 minus 3i is a complex number because it has a real number and it has an imaginary number, and we're subtracting them. 2 plus I is an imaginary number because there's a real number, a 2, an imaginary number, I, and we're adding them, right? It's just a sum or a difference, addition or subtraction of a real number plus or minus an imaginary number. Okay, so another one, I can take this -3. I can add I square root of 5. That's an imaginary number or a complex number. Okay, so in this lesson, what we're going to do with these complex numbers is we're just going to add them, subtract them, multiply them. All right, So, for example, let's add them together. 17 minus 6i minus 9 plus 10i. Okay? So how do you guys think we're going to add these numbers up? Let's have a conversation. How do you think we're going to add these numbers up? Or how do you think we're going to subtract these numbers? Box and FOIL. We're going to get into foiling later when we multiply, but we don't FOIL when we're subtracting. Combine the like terms. That's all we're doing. We're just combining the like terms. So we're going to subtract, because we're subtracting, the real components. So 17 minus 9. Oops. 9. Right? Minus negative 6 plus, or negative 6 minus 10i. Okay? Yeah, we're just combining the like terms. What's even simpler, which I didn't go over, which I will right now. If I had 17 minus 6i minus 9 plus 10i, my first step here would just be to distribute this negative. Okay? That would be easier for you to kind of comprehend all of this. So then now we have 17 minus 9 plus negative 6 minus 10i, negative 6i minus 10i. Right? Either way would work. And since we're subtracting already, the subtraction now turns into a addition, right? And since I distributed out the negative here, the subtraction turns into an addition. Okay? So 17 minus 9 is? Seventeen minus 9 is 8 plus negative 6i minus 10i. Yeah. Negative 16i, right? So then we're going to have 8 minus 16i. Right? And we get the same thing here. 17 minus 9 is 8 plus negative 16i. So it's going to be 8 minus 16i. Okay? Simple, right? We're just gathering our like terms. There's no need to overthink it. Okay? Yeah, cool. Let's now go with this example. 16 plus 17i plus negative 8 minus 12i. Okay? So since we're just adding them, we can go 16 minus 8 because those are the real components, right? 16 minus 8 plus 17i and negative 12i. So 17i minus 12i, right? So 16 minus 8 is 8 plus 17i minus 12i, 5i. That's it. And then we're done, right? We've collected the like terms basically, right? And we simplify where we can simplify. Cool? Easy? Questions? No? All right, now let's get into multiplication. Okay, when we multiply 4 plus 9i times 6 minus 2i, we're going to use FOIL. Okay, we're going to FOIL them out. Okay, remember what FOIL means. F is first. So the first two, 4 times 6 is, you know what, let me just put it here. 4 times 6, okay? The O in FOIL is outside or outer. Okay. So I'm going to go 4 times negative 2i. So just go plus 4 times negative 2i. Okay. The I in FOIL is inside. So the two inside ones, negative 9 or positive 9i times 6. And then the L in FOIL is last. The two last terms, right? Which would be 9i times negative 2i. Okay? Right? That's all we're doing. We're just FOILing it out. Yes. Sure. You can use the box method. You can use any method that you've learned in module 8, I believe. I believe that's when we did FOILing and we multiplied to binomials. You can go ahead and use that as well. Okay. Okay, so 4, and then we're just simplifying, right? 4 times 6 is 24. 4 times negative 2i, negative 8i. That's just negative 8i. 4 times 2 is 8, right? Or 4 times negative 2 is negative 8. 9i times 6 is 54i. And then 9i times negative 2i. Anyone know that? Negative 18i. There's I times I though. I squared. Okay? Can you guys see that? And now we're just going to gather the like terms. Okay? But before we gather the like terms, what is I squared? What is I squared equal to? Negative 1. So this, if I simplify this out, it's negative 18 times negative 1, correct? Yeah? Because I squared equals negative 1, right? And the reason why we did that is I squared equals negative 1. We substituted that in for I squared. And then what's a negative times a negative? A positive. So positive 18, that is the simplification of this, right? So whenever you see a number I squared, all we're doing, class, is we're just switching the sign, okay? So from here on out, I'm just going to switch the sign, okay? I showed you guys the reason why we just switched the sign. Now I'm just going to use the shortcut, and I'm just going to switch the sign. Okay, if it's a positive 18i squared, it just becomes negative 18. Okay, if it's a negative 18i squared, it just becomes a positive 18. Okay, we're literally just switching the sign. We're just getting rid of the I squared. Okay, so positive 18 plus 24 is 42. What is negative 8i plus 54i? Plus, 46i. And that's your answer. Okay? All right. Let's try another one. And I'm going to use the box method now because you guys, some of you guys do use the box method. -3 plus 12i times 7 plus 4i. Okay, the box method, you would put -3 plus 12i, make a box, right? And then down here, we would have 7 and then plus 4i, right? Yeah, like that. So the box method, you just multiply the top and the vertical with the horizontal. So -3 times 7 is -21. -3 times 4i is -12i. 7 times 12i. What is 7 times 12? 84i. And then 12i times 4i. What is 4 times 12? 48i squared then, right? Yeah. So we can rewrite it as one sentence. We can go -21 minus 12i plus 84i plus 48i squared. Now I see an I squared again. Okay? I know I'm going to be multiplying by a -1. So that I squared cancels out. The positive becomes a negative. That's all I'm going to do. Any questions on this? And why I did this? Yeah? No? So when we combine the like terms, -48, -21, that becomes -61, 9. Yeah. -12i plus 84i, that becomes positive 72i. And that's it. Okay. Cool. I do want to cover one more multiplication. Okay. 3 minus 2i times 3 plus 2i. Now, before I go ahead and FOIL or box method this, what does this look like? It's a special form, right? It's a difference of squares, correct? Yeah, we see that? So this is in the form of a minus b times a plus b, right? What does a minus b times a plus b, what is that equal to? No, close. What is that equal to? A minus b times a plus b. It comes out to be a squared minus b squared. And I'll show you guys why in this example. Okay? This is our special form right here. And I'll show you guys why it's a squared minus b squared. Okay? By foiling this out. F in FOIL is first. So 3 times 3, that's 3 squared. I'm going to put it as 3 squared for now just to show you guys. Okay? O in FOIL is outside. So 3 times 2i, that's positive 6i. Right? The I in FOIL is inside, so -2i times 3, that's -6i. And then the last one in FOIL, the L in FOIL is last, so -2i times 2i, that's -12i. 2i, and I want to put in parentheses squared. Right? Breaks out to be that, correct? Any questions on how I broke it down? No? So these two guys, 6i and negative 6i, they cancel out, right? And look what we have left. We have a squared, which is the first term squared, and we have minus b squared, right? Which is the last term squared. Yeah? And all we're doing here is just simplifying this guy. Okay? So let's simplify that with that being 9. Minus this squared goes to both the 2 and the I. So it becomes 2 squared, which is 4, I squared. Okay? You guys see that? So I said negative or positive 2i squared becomes 4i squared. Okay? And that's why I got this. Right? So remember, whenever I see an I squared, I'm just going to cancel that out, put a positive. Right? Because we're just multiplying it by negative 1. So negative 4 times negative 1 equals positive 4. Right? And what's 9 plus 4? What's 9 plus 4? Zach, what's 9 plus 4? 13. Thank you. Thank you, thank you, thank you. Yeah? So our I is just poof. They went away. Okay? Now I need you guys to remember that. That my I went away. All right? Because later down the line, we're going to use this to our advantage to get rid of the I's. Okay? Not rid of your I's, but get rid of the imaginary number I. Yes. Yes. Well, there's a negative out here. This? Because then if I take this, if I simplify this now, it's going to be equal to negative 4. But what did I add for? Because there was a negative out here. So it's minus 4. It was minus 2i squared, right? Yeah. That's why this negative times this negative turned into a positive. Yeah. Okay? Cool? Questions? No questions? That is your lesson for today, class. And